Hi everyone. In this lesson I want to talk about several ways that we can evaluate a polynomial function. Now we can certainly evaluate it by hand. This is the way that I suspect most of you already know how to evaluate a polynomial. So if this is my polynomial, this is a function, and if I want to evaluate it at -2, that just means that -2 is going to take the place of x here. So I'd get -2 times -2 cubed. I'm going to, every place there's an x, I'll replace it with -2, minus 3 times -2 squared plus the -2 minus 4. So that's going to give me what? -2 times -8, because -2 cubed is -2 times -2 times -2. And then I'll get minus 3 here. -2 squared is 4. And then I got a -2 and a -4. I can go ahead and just add those together. That's going to be minus 6. So I'll have 16 here, and 16 minus 12 is 4, and 4 minus 6 more is -2. Okay, so that method of course involves quite a bit of computation, either in your head or paper and pencil, or just plugging the numbers individually into your calculator. Alright, so I also want to show you using the graphing calculator what you can do, how you can do this maybe more simply, especially if you're evaluating a lot of things. So if you go to your y equals button right here on your graphing calculator, you can put your polynomial function in up here as one of the functions as if you're going to graph it. -2, here's your x right there, raised to the third power, minus 3x squared. Here's the square button right there, plus x minus 4. Okay, and so rather than graphing it, there is a table feature on your calculator. There's a table setup, and then there's the table itself. If you go to the table setup, there's a couple options here. You can have it automatically generate a table, and then you'd get a whole bunch of values. If you leave it on automatic right here, if you wanted to start, if I wanted at -2, I might want to start back at, like, say I'll just start at like a -6. And the little triangle here, that means delta table. That's a change. The table is going to change by 1, so we'll go -6, -5, -4. And if this is all set on automatic, then you can go to the table over here, and notice I hit the second button first, and just very quickly you generate a table that has not just -2 that we found by hand to be -2, but it also has many others as well. Now if you want to have the table so that it's not just automatic and you just plug in values, you can go over here and put the independent variable, that's your x value, on ask, and then when you go to the table feature, nothing is there, and you can just plug in, -2, and you get the -2 that we got by hand. You could plug in 0 if you wanted to. You could plug in minus 6 again. Alright, and then you can put them in whatever order that you want. Alright, so that's how you would do that using the table feature of the calculator. One other way that you can use the calculator that sort of makes use of the function notation is, once you have entered your function here in y1 is kind of like p that we're using in our hand notation. And so what you could do at your home screen, if you quit and go to your home screen, if you could find y1 on your calculator and then just put y1 of -2, we would expect that to do the same thing. So we need to find y1. That's over here under your variables button. If you go over into the y variables, and it is a function variable, there's y1. Okay, so if I hit that, and then I can hit y1 of -2, and it'll do exactly what I would expect it to do in terms of a function. It's going to plug -2 in there, and out comes -2. If I wanted other values at my home screen, I could use my second entry button right here that brings up the previous one, and then I could just change that -2 to, like, say -6, and it would evaluate it at -6. Okay, so that's how we would do those using our graphing calculator. And so if we have a lot of things we want to evaluate, we definitely want to make use of our computer technology to make it easier on ourselves. Okay, so let's go to this remaining problem. Here's an example evaluating polynomials, and they've also provided us a graph over here says that gentamicin is an antibiotic frequently used by veterinarians, and lots of big words here. The concentration in micrograms per milliliters of this antibiotic in a horse's bloodstream so many hours after injection can be approximated by this polynomial function. That just looks really nasty. But they have graphed that over here, and the purpose of this is to see that you can get a lot of information from the graph and avoid a lot of the nastiness of dealing with the actual numbers once they're in a computer, or if they are nice enough to provide you the graph. So in this case, it says to estimate the concentration of this drug in the bloodstream 4 hours after injection. So you can just come right over here to 4 hours, and you can go up to about, looks like it's about right here, and you'd guess that it's about 6, between 6 and 7. So we'd say, it's approximately 6.5, and that's the concentration, and we can go ahead and put the units on there, right? Micrograms per milliliter. Okay, and all that is determined just almost immediately from the graph. You can say, oh, it's, the maximum concentration is going to be up here about 10 micrograms, and that's going to happen at about 6.5 hours, and after a little over 9 hours, then it's going to be completely gone. In fact, that's the answer to the next question. Approximate the domain where this function lives is when this drug is in the horse's bloodstream, and that's only from time 0 to about time, what we say, 9.2, 9.3, maybe something like that. And it does say approximate, so it doesn't have to be exact, but that would be the approximate domain where the function lives. That the only x's that are going to make sense in this, because after the little over 9 hours, the horse's body will have broken it down, and there presumably won't be any left in it. The other thing I was just going to point out here is, in theory, if we did this correctly, I should be able to plug the 4 hours into this, right? T is time. If I plug 4 hours into this formula, I should get a value that's close to 6.5. So let me bring my calculator up here, and let's go ahead. Since I only need one value, I think I'll do this just right from my home screen here, and that's maybe the very easiest because I don't have to go anywhere else, and I'm only going to plug it in once. So what I'm going to do is I'm going to take the 4 hours, I'm going to store that as x, because I have an x button right here, and that's easier to access than hitting alpha and t. So I'm just going to store that as x, and then I'm just going to plug this in. I'm going to put negative 0.005 x to the 4th power plus 0.003 x to the 3rd power plus 0.35 x squared, and then plus 0.5x. And when I hit enter, that will have replaced x with 4, and hopefully we'll get something close to 6.5, which is what it's supposed to be on the graph right there. And sure enough, that does give me about 6.512. Okay?